Understanding the giants. What is an ICBM? Imagine a rocket, but not just any rocket. This rocket is a giant, capable of traveling thousands of miles. It carries a dangerous payload, one that could cause unimaginable destruction. This, my friends, is an Intercontinental Ballistic Missile, or ICBM for short. ICBMs are not your average missiles. They are designed for one purpose: to deliver nuclear warheads to targets across continents. These behemoths of destruction are the ultimate weapon, a terrifying reminder of humanity's capacity for self-annihilation. The sheer power of an ICBM is awe-inspiring, yet terrifying. Imagine the energy needed to hurl an object weighing several tons over a distance greater than the width of an ocean. That's the kind of power we're talking about. But raw power is not enough. To reach their targets with pinpoint accuracy, ICBMs rely on a complex interplay of physics, engineering, and technological marvels that continue to push the boundaries of human ingenuity. Igniting the fury, the boost phase of an ICBM. The journey of an ICBM begins with a fiery roar that shatters the silence. This is the boost phase, the initial stage of the missile's flight, where immense power is unleashed to propel it skyward. Imagine a colossal rocket engine fueled by a mixture of liquid or solid propellants igniting with a force that shakes the ground beneath. This powerful thrust propels the ICBM upwards, overcoming the relentless pull of Earth's gravity. As the missile ascends, it gains speed at an astonishing rate. The air around it screams as the ICBM slices through the atmosphere, leaving a trail of fire and smoke in its wake. This initial burst of energy is crucial for the ICBM's mission. It's during the boost phase that the missile gains the necessary velocity and altitude to escape the Earth's atmosphere and begin its long journey towards its target. Parting ways, stage separation in ICBM flight. As the ICBM roars higher, it sheds weight like a snake shedding its skin. This stage separation conserves fuel and maximizes range. Each stage has its own engine and fuel. The first stage provides the initial boost. Once depleted, it detaches and falls back to Earth. The second stage then ignites, propelling the ICBM higher. Stage separation repeats, bringing the ICBM closer to its target. Navigating the void guidance systems of ICBMs. With the Earth shrinking below, the ICBM enters the vast expanse of space. Here in the cold vacuum, it relies on sophisticated guidance systems to stay on course and reach its intended target thousands of miles away. Imagine a network of gyroscopes, accelerometers, and computers working in perfect harmony to track the missile's position, velocity, and trajectory with incredible accuracy. These systems constantly monitor the ICBM's flight path, making minute adjustments to ensure it stays on target. In the early days of ICBMs, guidance systems were relatively primitive, relying on inertial navigation systems that were prone to errors over long distances. However, modern ICBMs utilize advanced guidance systems such as star trackers and GPS to achieve pinpoint accuracy. These guidance systems are the brains of the ICBM, constantly calculating, adjusting, and guiding the missile towards its destination with unwavering precision. Section 5. The silent ballet, the midcourse phase. With the boost phase complete and its trajectory set, the ICBM enters the midcourse phase, the longest and arguably most uneventful part of its journey. Here, high above the Earth, the missile coasts silently through the vacuum of space. Imagine the ICBM as a solitary traveler, gliding effortlessly through the darkness, its fiery trail long extinguished. It's a time of relative peace, but also one of anticipation, as the missile hurtles towards its target at hypersonic speeds. During the midcourse phase, the ICBM may deploy decoys and countermeasures to confuse enemy radar systems and increase its chances of survival. These decoys mimic the radar signature of the actual warhead, making it difficult for enemy defenses to distinguish between the real threat and the fakes. The midcourse phase is a game of cat and mouse, with the ICBM attempting to evade detection, while enemy radar systems scan the skies searching for any sign of the incoming threat. Section 6. Falling back to Earth, the re-entry phase. As the ICBM approaches its target, its peaceful journey comes to an end. It's time for the re-entry phase, a fiery and violent descent back into the Earth's atmosphere. Imagine the ICBM, no longer a silent traveler, but a meteor plunging back to Earth at incredible speed. The intense friction generated by the atmosphere superheats the missile's protective shield, creating a fiery glow that illuminates the sky. This heat shield, made of ablative materials, is crucial for the ICBM's survival during re-entry. It absorbs the intense heat, preventing the missile from burning up like a shooting star. As the ICBM descends through the atmosphere, it maneuvers, adjusting its trajectory to reach its intended target with pinpoint accuracy. This is a critical phase, as even a slight deviation can result in the missile missing its target by miles. Section 7, the heart of the beast propulsion systems in ICBMs. At the heart of every ICBM lies its propulsion system, a marvel of engineering. Imagine powerful engines fueled by liquid or solid propellants burning hotter than the sun. These engines generate incredible thrust, propelling the ICBM skyward. The choice of propulsion system depends on the ICBM's design and requirements. Section 8. Targets in sight, warheads, and their deployment. The ultimate purpose of an ICBM is to deliver its deadly payload to the target. This payload, consisting of one or more nuclear warheads, has the potential to cause unimaginable destruction. Imagine these warheads, each containing the destructive power of thousands of tons of TNT nestled within the ICBM's nose cone. These are not mere bombs, they are weapons of mass destruction capable of obliterating entire cities in an instant. As the ICBM approaches its target, it releases its warheads, which then follow independent trajectories towards their designated points of impact. This multiple, independently targetable re-entry vehicle, MIRV technology, allows a single ICBM to strike multiple targets simultaneously, increasing its destructive potential. The detonation of a nuclear warhead triggers a chain reaction that releases an immense amount of energy in the form of heat, light, and radiation. This blast wave can level buildings for miles around, while the ensuing fallout can contaminate vast areas with deadly radioactive material. Section 9, a delicate balance of terror ICBMs in modern warfare. The development and deployment of ICBMs have had a profound impact on global politics and warfare. These weapons of mass destruction have ushered in an era of nuclear deterrence, where the fear of retaliation prevents any nation from using them first. Imagine a world held hostage by the threat of nuclear annihilation, where the mere existence of ICBMs serves as a deterrent against large-scale conflict. This is the reality of the nuclear age, a delicate balance of terror that has prevented another world war. The possession of ICBMs gives a nation significant military and political clout. It's a symbol of power and a deterrent against aggression, as any attack could be met with a devastating nuclear response. However, the existence of ICBMs also poses a significant risk to humanity. The accidental launch of even a single missile could have catastrophic consequences, potentially triggering a global nuclear conflict. Section 10, the future of ICBMs, advancements and challenges. As technology continues to advance, so too do the capabilities of ICBMs. New propulsion systems, guidance systems, and warhead designs are constantly being developed, making these weapons even more sophisticated and deadly. Imagine hypersonic ICBMs, capable of traveling at speeds exceeding Mach 5, making them virtually impossible to intercept. Or imagine missiles armed with maneuverable warheads that can evade enemy defenses, ensuring the destruction of their targets. These advancements pose significant challenges for international security. The development of hypersonic missiles and other advanced technologies could undermine the existing nuclear deterrent, making the world a more dangerous place. The international community faces the daunting task of finding ways to control the proliferation of ICBMs and prevent a new arms race. This requires diplomacy, cooperation, and a shared understanding of the risks posed by these weapons of mass destruction. Section 11, Conclusion, a legacy of fear and deterrence. Intercontinental ballistic missiles, with their immense power and destructive potential, have become an enduring symbol of the nuclear age. They are a reminder of humanity's capacity for both innovation and self-destruction. While ICBMs have ushered in an era of nuclear deterrence, preventing large-scale conflicts, they also pose a significant threat to our existence. The accidental launch of even a single missile could have catastrophic consequences for humanity. As we move forward, it's crucial that we find ways to manage the risks posed by these weapons of mass destruction. This requires international cooperation, diplomacy, and a commitment to arms control. The future of our planet may very well depend on it.